because perpendicular bisector is where we have a line segment. A segment like this, usually it's that we'll have like an A and a B. If we have a midpoint, the line that goes through the midpoint and is perpendicular, that's when we have a perpendicular bisector. Those two pieces would be the same length. And the way we're going to test that, the way we're going to use this is if this is a perpendicular bisector, this distance will be the exact same to both A and D. So if we have a point on this perpendicular bisector, they will have the exact same distance. No matter which side of the perpendicular bisector it's on. If it's even like way down here, these two segments would have the exact same distance. So if we have a point that is on the perpendicular bisector, then it is going to be exactly equidistant to the endpoints of the line. So what we're going to have first when we're given problems like this is we're going to be given our two endpoints, and we're going to be given another point that we're going to test and see if it's on the perpendicular bisector. So, I'll you all right for a second. Okay. So our first one like this is we are asked to prove, meaning we got to show, that C is on the perpendicular bisector of AB. We don't have to plot this up. Can if you want to. But what they're saying is if we have a segment that goes from A to B, we want to see if C is exactly the same distance from A that it is from B. Those two distances should be exactly the same if C is on the perpendicular bisector. So we need to find the distance between A and C, and we need to find the distance between B and C. So we're going to do two different setups for this. So we're going to find the distance from point A to point C. So we're going to find that segment. We want to find its distance. So we're going to use our distance formula. That's our square root of the changes in our x's squared. So my A, we have -4. C, we have 5. And we square that. So the change in my x's plus the change in my y's. So we're going to have our -3 minus -11. And we need to square that too. So just filling in our distance formula. We're going to simplify this as much as we can. We don't need to get all the way down to a decimal answer. Once we get it down as simplified as we can stop right there. So we're going to have our square root of -4 minus 5 gives us a -9 to square. And then we're going to do the same thing on the right-hand one. Let me stylish aside. This is not going to be gross anymore. And then we can have our 3 minus -11. I'm sorry, -3 minus -11. +8 squared. So then we have -9 squared, which is a +81, and 8 squared, which is a 64. 81 plus 64 gives us 145. And we're going to stop right there on that simplified. We don't need to get a decimal. It doesn't really simplify into a simplified radical form, and we don't really need it anyway. That's giving us our distance from point A to point C. So that means we know this guy is square root of 145. Now we need to figure out this one. So we need to find the distance from C to B. So we're going to find the distance from C to B. Do not know if I'm going to have enough space for that, but let's give it a go. So we're going to have our square root of the change in our x's. So we have our 6 minus 5 squared. And the change in our y's, 1 minus negative 11 squared. So again, simplifying as far as we can go. 6 minus 5 gives us a 1 squared, bless you. And 1 minus negative 11, that's going to give us 12 squared. So that's going to give us 1, and 12 squared is actually 144. So the distance between point C and point B is the square root of 145. So is point C on the perpendicular bisector?
Yes.
Yeah. Because the distance between A and C is exactly the same as the distance between C and B. That was a weird shape, but that's okay. C is on the perpendicular bisector. So C is on the perpendicular. If you don't want to have to write up perpendicular, the symbol for that is kind of an upside down capital T. Means perpendicular bisector. Because the distance from A to C equals the distance from B to C. So C is on the perpendicular bisector of segment AB. This counts as proof. We don't need to set it up as a geometric 2-column proof. This is proof. We've proved it. Because the only way that this works is if C is on the perpendicular bisector. Okay. Questions on the first one of these? Because we're going to do another one. Like this. Because sometimes we'll get things that are fractiony and unpleasant. Oh, sorry, there we go. So again, we want to prove that C is on the perpendicular bisector of segment AB. C has a fraction in it, but that's okay. We can do this. We're going to set this up exactly the same way. We're going to find our distance from A to C. And we're going to find our distance from B to C. Because we want to see that C is on the perpendicular bisector. So we're going to find our distance. From A to C, our change in our x's, we're going to have our 1 minus 4 squared. And you can do those in the opposite order if you want. If you do it as 4 minus 1, that's totally fine. And we're going to have the change in our y's. 7 minus 1/2 squared. And again, we're going to simplify this as much as we can. So we're going to have our 1 minus 4, that gives us a negative 3 to square. And our 7 minus 1/2, well, that'll be 6.5. But if we write that as a fraction, that would be 13 halves. Improper fractions are usually easier to square than a mixed number or a decimal would work easier than a mixed number. Mixed numbers are probably the hardest way to go about it. So then we're going to simplify this even more. We're going to square both of these. Negative 3 squared gives us a 9. And 13 halves squared, 169 over 4. Square the numerator and square the denominator. Then we need to add those together, which we can, either do in the calculator or we can do by hand. Because 9 in terms of fours would be 36 fourths. So 36 fourths plus 169 fourths gives us 205 fourths. And all we could really care about is, are the distances equal? So we don't have to get to a decimal answer. We don't have to simplify it. We just care, are they the same? You can simplify it if you want to, but it's not going to be pleasant. All we care about is, are the distances the same? So it doesn't matter how pretty it is. I will be able to compare square root of 205 over 4 to whatever the heck I get over here and see if they're the same. So then let's do our other distance. We did from A to C. Now let's do from B to C. That's going to give us our square root of the change in our x's. So we're going to have our -3 minus 4 that we square. And we're going to add to it the change in our y's. 2 minus 1/2 squared. It's all about how they change, how far they've moved. So that's going to give us our 3 minus 4 gives us a -7. And 2 minus 1/2 is 1.5, but I'm going to write that as an improper fraction, so I'm going to put that as my 3/2 to square, because it's easier to square that. Because then I just need to square numerator, square denominator, and we're good. Because what we have here is square root of -7 squared gives us 49. And 3/2 squared gives us 9 fourths. And again, I want to combine my like terms together. So 49 plus 9 fourths. What is that going to be when we combine those together into one fraction? Because 49 is going to be 196 fourths plus 9. That will give us our 205 over 4. So since our distance from A to C is exactly the same as the distance from B to C, C has to be on the perpendicular bisector. So my answer would say, because the distance from A to C equals the distance from B to C, C is on the perpendicular bisector. Spelling is a suggestion. I can never remember if it's O-R or E-R. I think it's O-R because it doesn't give me squiggles on my Google slide. But, spelling is a suggestion. I don't care how we spell it. Okay. Questions on this one? So if we're just testing points, it's not too obvious. Sometimes they're going to give it to us in a slightly different way. Of course they are.
When do they not?
I know. So now we're given A and B, and we're trying to find an equation for our midpoint, or an equation for that perpendicular bisector. So they've decided to call this random point that's supposed to be on our perpendicular bisector point P. And what we know about point P is, if it's on the perpendicular bisector, the distance between point A and point P would be exactly equal to the distance between point B and point P. Because if P is on that perpendicular bisector, the distances will be the same. Well, I could write an equation for the distance between point A and point B, P. And I could write an equation for the distance between point B and point P. And so that's what we're going to do. So the distance between point A and point P, we're going to use our distance formula. And we're going to find the change in our x's. Well, we know the x of A is 1, but we don't know what the x is for P. So we're going to just minus our x squared. And I know what my y values are for A. That's going to be 7. But I don't know what the value is for point P, so we're going to use the letter y squared. And I can do the same thing for the distance between point B and point P. I can put that into my distance formula. Again, I know the x value of B is -3, but we don't have a point x for P, so we're just going to use the variable. And the same thing for our y's. 2 minus my y squared. That's a plus. So if they don't give us an actual point and they want us to find it, or find a formula, we're going to have to set those two distances equal, because if P is on that perpendicular bisector, it's going to be an equal distance. Now we're going to try and figure out how to solve this dang on thing. What can I do to this thing? Square both sides. I've got square roots on both sides. I don't want to have square roots on both sides. So if I square both sides, both of those square roots cancel out, and we're left with our 1 minus x squared plus 7 minus y squared. Is that equal to -3 minus x squared plus 2 minus y squared. So we got rid of all those square roots. Yay! Now what could we do? Those are separate lines. There we go. What could I do to try and simplify this a little bit? It's going to look grosser for a second. We're going to square all the things. So our 1 minus x squared, we're going to need to square that out. My 1 is minus x times 1 minus x. It's going to give us a 1 times 1 minus 1 times minus x. We have minus 2x plus x squared. Minus x times minus x. That's that guy. And then we're going to have this one that we multiply out. And if you take a couple lines to do this, that's totally okay. If you want to do boxes, totally valid. I don't care how we multiply it out, just that we multiply it out. So we're going to add in our 7 minus y squared. So 7 times 7 gives us 49. Minus 7y minus 7y gives us minus 14y. Plus minus y times minus y, y squared. Same thing on the other side. So we're going to have our minus 3 minus x. And we're going to have minus 3 times minus 3 giving us a positive 9. My minus x times minus 3 gives me a plus 3x. And then another plus 3x, we get plus 6x. And minus x times minus x gives me a plus x squared. And one more set of these. Is that sure? Okay, yeah, kind of. So then we're going to have our 2 times 2 gives us 4. Oh, that's a little too light. I'll get a slightly darker one. do that one. So we're going to have our plus 2 times 2 gives us 4. Minus 2y minus 2y, we get minus 4y plus y squared. If we don't like having the x's and y's at the end, it is 100% okay if when we're setting these up, we flip-flop them so that we're subtracting the x minus 2, x minus negative 3. We'll get the exact same pieces here. So if you don't like having this, 2 minus y squared, you could have it be y minus 2. Like, it doesn't matter what order we subtract things. It's which one is 0.1 and which one is 0.2. So this got a little bit gross here for a second. But we could do some simplifying here. If I subtract x squared from this side, trying to get my x squareds together, and subtract x squared from this side, those cancel out. Woohoo! And in fact, the same thing happens with my y squareds. If I do minus my y squared from both sides, those guys also cancel out. So then when we do a little bit of combining some like terms, I'm going to combine my whole numbers together here just so we can see. We've got 50 minus 2x minus 14y equals our 9 and our 4. We've got 13 plus 6x minus 4y. And it is still unpleasant and ugly, but it's not squared anywhere. It's a linear equation, so let's make this look like a linear equation. I'm going to do this just so I can get a little more space here. There we go. What can I do now? Or what do we choose to do now? Lots of options on what to do. Subtract 13. Let's get our constants together. Minus 13. There we go. So that will give us our... My brain stopped.
36.
I was going to say, I thought it was 36. But, yeah, no, 37. Minus 2x minus 14y equals 6x minus 4y. I don't like having two y's. Say it a little louder, I can't hear. Yeah, let's add our 14y to both sides. You can do that and have it be like more of a slope-intercept style vibe, or we can add the 2y, or the 2x's, and get this to look like kind of a standard form equation. It doesn't really matter how this looks, but we want to just have one set of x's, one set of y's. Because this is going to give us that 37 equals 8x plus 10y. What this winds up being when we write it like this is the equation for the perpendicular bisector. I could get that into slope-intercept form. I could graph that. It would cut the segment AB in half at a perpendicular angle. So at a perfect 90 degree. It's unpleasant and kind of gross. But if they're just giving you a point x, y, they're saying you just use x and y, we're going to wind up with an equation. Okay. All right, before we get into some more practice stuff, I'm going to give us one other formula to look at, because we will have times where we need to find the midpoint.
Ew.
It looks icky. I promise it's not that bad. So if we're given 2 points, x1, y1, x2, y2, just like we had for our distance formula. to find that midpoint, you average the x's and you average the y's. So x1 plus x2 divide by 2, because there's only two things there. y1, y2, add those together, divide by 2. There's only two things there. So you're averaging your x and your y. That's how we're finding our midpoint. You could also find your distance, cut it in half, but then we have to find where the next point is, and it's unpleasant. So the midpoint is all about finding the average in your x's and the average in your y's. So now we're going to actually find the midpoint of this segment here. So we're given that A is 7, -3, and that B is 3, -8. And we want to find the midpoint. So to find our midpoint, we're going to take the x's and average them. So I'm going to take my x of 7 plus my x of 3 and divide by 2. 7 plus 3 gives me 10, divided by 2. So my new point, the midpoint, is going to have an, I'm going to call it M, is going to have an x value where? What is 10 divided by 2? 5. So the B was at 3, A is at 7, halfway between those, the midpoint is going to be at 5. So we take our 7 plus 3, divided by 2. We're going to do the same thing for the y's. We're going to have our -3 plus our -8 and divide it by 2. And again, it doesn't matter what order we put these things in. So if you find it easier to do -8 plus -3, totally valid. We add them together. So -8 plus -3 is going to give us -11 divided by 2, which is going to be a decimal. So we can either put it as a decimal, since it is a terminating decimal, we can do that. If we wind up with something like thirds, do not round it. You've changed your answer. We're going to leave things as fractions if we can't get a terminating decimal. So I'm just going to leave this as my -11/2. And that's the y value of my midpoint. So our midpoint here is the point 5, -11/2. Or -5.5. Okay? So average your x's, average your y's. Simplify as much as we can. Okay, finding the midpoint itself, not usually super gross. But that means they're not going to give us tons like that. They're more likely to ask a question like this one, where they're giving us A and our midpoint of C, and we need to find B. So they're telling us A, this is where B is supposed to be, but all we know is C. But we know it should be the midpoint. So our A is that -4, 6. Our C is that 1, -3. And we don't know what B is yet. We have to figure it out. So I'm just going to call this X and Y for right now. We want to find that out. If C is the midpoint, I know it is the average of the X's and the average of the Y's. So I know whatever happens to my midpoint if I have my x's, my negative 4 plus x, and I divide it by 2, I should get exactly 1. If I take the x from my A and the x from my B and average them, I should wind up at C. How can I figure out what x is going to be? Multiply both sides by 2. We get negative 4 plus x equals 2. What do you do next? Add 4 to both sides. So the x value of point B, 2 plus 4 gives us 6. So B is going to be with an x value of 6. We're going to do the same thing to find the y. I know that whatever the y value of A is, plus the y value of B, divided by 2, should equal our negative 3. So we're going to take our 6 plus our y divided by 2 should equal that negative 3. Because if I know the endpoints, I can find the midpoint. So now if I know one endpoint and the midpoint, I can find the other endpoint. And again, we're going to follow that same kind of process. We're going to multiply both sides by 2. That's going to give us that our 6 plus y equals negative 6. So what's our y going to be?
0.
Careful. Negative 12. Minus the 6. That'll be like the super most common, 100%. I guarantee you other people have made that exact same mistake. Negative 12. We get into the things that are adding and subtracting, and we're like, oh, yeah, done. And we zip through that, and we're like, the signs. Signs kick us in the teeth every time. So be really, really careful, because it's very, very easy to do exactly that. And be like, oh, well, the 6 is flat. Done, 0. Not like that. You just got to be really careful. So B would be the point 6, negative 12. They love to write questions in that way. They love to. So make sure we're reading carefully and that we are looking at our endpoints actually as our endpoints. Just because they give us the 2 points doesn't mean it's the endpoint. Okay, just be careful. Questions on this one? Let's see where we are. Okay. So we're going to look at this one. This is kind of combining a few different things. We're going to find all the points on our y-axis that are a distance of 6 from this point. So I want to know things that are a distance of 6. So when in doubt, we're going to think about the distance formula. Because we're going to find a point, or all points. I'm just going to call them x, comma, y. So if I know that my distance between point P and my anything, let's see, I'm going to call it A just so we have a name. P and my anything. We can find a distance for that. We've got a distance formula. We can do our 5 minus x squared plus our 3 minus y. So, oh, yep. So I'm just filling in my distance formula with the pieces we know. I know we have a point, and I want to find some more points. So if we're going to find more points, I need to at least get some letters in there. We want them to be a distance of 6, and we want them to be on the y-axis. So if I need them to be a distance of 6, means I actually know what number is going to go here. 6. And if we want points to be on the y-axis, we actually know a little bit more too. If it's on the y-axis, that means my x is 0. So this guy's just going to be 0. So I could rewrite this as my 5 minus 0 squared plus my 3 minus y squared. And now we've got stuff we can work with. I can get down to a y equals now. We have lots of steps we can do in lots of different orders. So what should we do first? We can square both sides. I can square this side for my 6, and I can square this side to get rid of that square root. That's going to give me that a 36 equals our square, no square root. Square root cancels out. We've got our 5 minus 0. That's just going to give us our 5 squared. But you can write it as our 5 squared, or you can multiply that out right there. And then we're also going to have our 3 minus y squared. And again, we're going to multiply some stuff out. So we're going to have that our 36 equals 5 squared gives us 25, plus our 3 times 3 gives us 9, minus 6y plus y squared. I'm going to do a little bit of shuffling on us because I don't like having my y squared at the end. So I'm just going to rewrite things. We're going to have our 36 equals our y squared minus 6y. And I'm going to add together my 25 plus 9. That's going to give me a 34. What should we do now? Subtract the 36. We've got a quadratic. It's with y's, but it's fine. We've got a quadratic. So that means if we're trying to find a solution, we need to set this equal to 0. So we're going to minus 36 from both sides. So that gives us our 0 equals y squared minus 6y minus 2. How do we solve this? Yeah, it won't factor, so we're going to have to use the quadratic formula. So we're going to wind up with our y equals, it's not an x equals, it's a y equals, but it does the same thing. Our opposite of b, so opposite of negative 6, plus or minus the square root of our b squared. So it's going to be negative 6 squared. So I'm just going to put my negative 6 squared minus 4 times my a, which is 1, times my c, which is negative 2. Make sure you're multiplying all those pieces together. I've had a lot of people randomly switch to adding or subtracting in the middle, so please be careful. We're going to simplify as much as we can. We're not getting to decimals, but we are going to get simplified radical form. So we're going to have that our y equals, opposite of negative 6 is 6. We get plus or minus. 6 squared gives me 36. Minus 4 times 1 times minus 2 gives me a plus 8 over 2. Oh, that's good enough. So then we're going to have our 6 plus or minus the square root of 36 plus 8, 44 over 2. Does square root of 44 simplify? Because I could have 4 times 11, and 4 is a perfect square. So this is going to give us 6 plus or minus 2 root 11 over 2. And again, will it simplify? Yeah. Yep. 6 and 2 both divide by 2, and I'm dividing by 2. So our answer is going to be here are 3 plus or minus the square root of 11. So the points on my y-axis that are 6 away from the point they gave us are 3 plus the square root of 11 and 3 minus the square root of 11. Long one. Okay? The only other kind of problem that they really have in here is like the one we did with the triangle yesterday, where we had to prove it was a right triangle, but they want you to prove if it's a square, meaning it has 4 sides that are the same distance. We might need some perpendicular angles there, perpendicular bisectors. These need to be right angles, that kind of stuff. Okay, so make sure we're reading carefully, paying attention to the details. We have 2 minutes to the end, just putting these up here for now, so we have them. Okay, just make sure we're reading carefully. If you got questions, let me know about stuff. That's where we're going to stop for today.